Okay, let's consider the partial pressure of a mixture of gases. So according to the ideal gas law, the gas particles don't interact with each other through attractions or repulsions, and so the partial pressure, if we have a mixture of gases, is just the pressure of the individual gases summed. So we can say the pressure total of a gas mixture is equal to the sum of the pressures of the individual gases. So say we have gas A and gas B, and their partial pressures are P sub A and P sub B, then the total pressure would just be the pressure of gas A plus the pressure of gas B in the container. Now, since the gases are in the same container, the volume and temperature are the same, and so we can say the total pressure is the sum of the partial pressures, which equals the sum of nRT over V. The only thing that's changing is the amounts of the gas. So we sum over the number of moles of the gas, and so we can say pressure total is RT over V times the summation over the number of moles of each gas. So another way of writing that is just pressure total is equal to the sum of NA plus NB plus NC plus however many components there are in the gas mixture times RT over the volume. So the way of writing that is saying pressure total is number of moles total times RT over V. Let's consider the fraction of, say, component A in the mixture. So if we have pressure of mixture of gas A over the total pressure, we can write that as N sub A RT over V for the pressure of gas A divided by N total for the total pressure times RT over V. And so since they are in the same container, RT over V is the same for both, and they cancel. So this was just the number of moles of A over the number of moles of B. Excuse me. That's N total. So I didn't write that very well. I was thinking of what I was doing next. So the fraction of pressures is NA over N total. This is given a special symbol, and it's called the mole fraction of A. It's just the moles of A over the total number of moles, and it's given the Greek letter chi. It means that P total, just solving this algebraically, is the mole fraction of that PA is equal to the mole fraction of A times P total. The most useful things here are mole fraction. So we have the mole fraction of ith component is equal to N sub I over N total, and that we have the pressure of the ith component is equal to the mole fraction of that component times the total pressure of the gas mixture.